Hello everyone, welcome to my new video. In today's video, we are going to carry on the optimization of the pole mechanism. We will do the simulation or say make the 3D animation to check is any collision between the pole and the flap. Also, we are going to use the pole to close this flap. We will check the dimension here is good enough to close this flap or not. All right, let's get it started. So first of all, let's go to the environment and studio animation. So this is the closed position. We will check the open position. So we retract the cylinder. This is open position. Environment, studio, animation. Okay. I don't think when the cylinder is extended, this point will close the flapper. So first of all, I'm gonna put some constraint. Say, so this constraint will detect the collision of this bit and this surface. So yep, I'm gonna show you how to use the constraint to do the collision mechanism. So tangent, let's do this surface and this surface, but instead of 100%, instead of the constraint or say rigid constraint, we will say minimum. That means when it is larger than 0, it's fine, but only when it's touching. So this side will push the flapper over this way. Okay, then we click OK. Then we go to the environment and studio animation. So first of all, I'm gonna increase another 2 seconds to allow the cylinder to extend or say close positioning mechanism or movement by 2 seconds. Then I'm gonna add some constraints there. So first of all, I needed to add constraints at second 10. So if we slowly move the thing to that. Um, we will add a constraint, and I think this is the cylinder. Um, that one. So from 25 to 0, then we need to specify timing. I think 15 seconds. The duration is 2 seconds. Okay, but we can see the robot is not level, so that means that is all because this constraint is suppressed, which is the vacuum cups. In other words, we need to add one constraint. So I needed the robot, or say this plate, horizontally placed all the time, or say leveled all the time instead of tweak. So this one, that will make an angle that, so that is 180 degrees. If I click that, should be fine. Which is plate, plate 2, angle 180 degrees. Okay. So I added one constraint. Lucky at this time there's no confliction of the other constraint. Am I correct? Yes. Let's do the animation to see if it is successful or not. Okay, now because the tip is not long enough and low enough, I'm gonna modify this position, and in other words, I will make this geometry a little bit down. So double click, you will do the local editing. This one, double click again to do the 2D sketch. So I don't think I can move the ball, or sorry, the the circle directly downwards because it connects to this one and that's line. I delete this one first, that one, and now I can move this one, the circle down to be here. Line. think that line is not happy. So I modified the dimension. Let's see the simulation is good or not. Nice. So at the moment it's not 100% 90 degrees or 100% folded. So what I'm gonna do, I'm gonna modify the dimension a little bit further down. I mean this one, this tip. To see whether I can reach the limit. Double click that again. Double click to do the 2D sketch. Delete. Delete. Move that thing further down a little bit, just to try to get down some limit of the simulation. Okay, much better. So, yep. In this video, I demonstrate how to use the simulation to optimize some geometry, and how to create a collision detection by using the tangent constraint. If you like my video, please subscribe. Thank you.